Hi students, in AI previous video lecture I will start the unit number 5 probabilistic reasoning, and in this unit I will complete the first topic probability and bias theorem. Now I will start the second topic of this unit number 5 certainty factors and rule based systems. Okay, so first the basic introduction is given, then two components are given for certainty factor. Okay, then its explanation is given. So I will start with the basic introduction. In this we are trying to describe a practical way of compromising on a pure Bayesian system. Here we can try to find out the practical way how we can compromise on a pure Bayesian system. We can learn the bias theorem in the previous video lecture. The equation and examples are completed. Now here we can learn the Bayesian system in the practical way. So here we will use the mycin as an example here, which use LISP and act as an expert system. Here we can use the MYCIN one system, and this system use the LISP. Okay, so here the MYCIN uses the rules to reason backwards to the clinical data available from its goal of finding significant disease causing organization. Here one medical example is given. Okay, in the mycin we can use the backward, and the clinical data are available, and from that data we can find out the significant data, means the disease and why they are occur, and how the organization can handle this disease. Okay, nowadays corona is very popular. Its first wave and second wave are completed. Now the third wave is coming. So the doctors and nursing staff will prepare for the third wave, and we all are the aware of the corona, so we can take care of ourselves. Okay, because we all are know that there is no particular medicine is given for this disease. So in this example the doctors are find out the causes for the particular disease. Okay, then each rule has a certainty attached to it. Once the identities of the organization are found, it then attempts to select a therapy by which the disease can be treated. Now here the rules are given, and we can attach the all reports. Okay, if you can not feel good, then you can go to the hospital and meet some doctor, and doctor say that you can lab test, you can make the lab test, then the reports are created and doctor check all the reports and then give the medicine. Okay, so this whole process some rules are used. Okay, so here we can use that rules and find out the solutions. Okay, why the diseases are created and how we can solve that disease or remove that disease causes. So here we can use the certainty factor. We can take the short form as a CFH, E is defined in terms of two components. Here we can use the two different components. Okay. First is MB in bracket H, E, a measure between 0 and 1 of belief in hypothesis H given the evidence E. Okay, here we can take the hypothesis H and evidence as a E. So here we can find out the certainty factor hypothesis comma evidence. Okay. Now MB measures the extent to which the evidence supports the hypothesis. Now we can measure the MB. How we can measure the MB? H, E, hypothesis and evidence. And we can measure between 0 and 1. Okay. Then it is 0 if the evidence fails to support the hypothesis. When our hypothesis can't support, then the system is failed, so we can take the value as a 0. And when our hypothesis will be run, we can get some output, so that situation we can take the 1. Okay. So this is the first component. Now the second component, MD H, E. So here we can assume between 0 and 1 of disbelief in hypothesis H given the evidence E. We can consider this second component. Okay. And in this component we can take the hypothesis H and evidence E, and we can measure the value of MD H, E. MD measures the extent to which the evidence supports the negation of the hypothesis, means the negativity, how the hypothesis will be generated. Okay, and it is 0 if the evidence support the hypothesis. 0 ક્યારે આવશે કે જ્યારે જે આપણને રિપોર્ટના આન્સર મળે છે એ કેવા હશે, હાઇપોથેસિસના સિમ્ટમ્સ બતાવતા હશે, બરાબર. તો ત્યારે આપણે એની વેલ્યુ 0 લેશું, અને જ્યારે એ સિમ્ટમ્સ નહીં બતાવશે ત્યારે આપણે હાઇપોથેસિસની વેલ્યુ 1 લેશું. ઓકે. અને છેલ્લે આપણે શું કરશું, આ જે ઇક્વેશન આપેલો છે એનો યુઝ કરીને આપણે સર્ટેનિટી ફેક્ટર ફાઇન્ડ આઉટ કરશું. સર્ટેનિટી ફેક્ટર H, E ઇઝ ઇક્વલ ટુ MB H, E માઇનસ MD H, E. ઓકે. એ બેઉ માટે આપણે આ બેઉ કમ્પોનન્ટનો યુઝ કર્યો, બરાબર. અને એની જે વેલ્યુ આવશે એને આપણે માઇનસ કરશું એટલે આપણને સર્ટેનિટી ફેક્ટર મળી જશે, બરાબર. શું આપેલું છે નેક્સ્ટ, સિન્સ એની પર્ટિક્યુલર પીસ ઓફ એવિડન્સ either supports or banish a hypothesis but not both, and since each Maysin rule corresponds to one piece of evidence, here we can find out the evidence, and if the evidence supports the hypothesis, okay, then we can say that Maysin rule satisfy. Okay, and a single number sufficient for each rule to define both MB and MD and thus the CF. Now here we can define the both rule. Okay, first is MB and second is MD, and then both rule we can find out the CF. We can use both rule, okay, and find out the certainty factor as we can learn in the above equation. Now, the certainty factor are provided by the expert who can write the rules, okay, and the rules reflects that the assessment, what is the strength of evidence, and it is support hypothesis or not. And that time certainty factor needs to be combined the reflect of the operation of multiple pieces of evidence and multiple rules applied to a problem. ઓકે, અલગ અલગ એવિડન્સ લેશે બરાબર અને ચેક કરશે કે જે બી ઓપરેશન પરફોર્મ થાય છે એનાથી સોલ્યુશન મળે છે કે નથી મળતું બરાબર. આપણે પણ ઘણીવાર સર્જરી કરાવીએ તો એ સક્સેસફુલ નહીં થતી પહેલી વખતે, બીજી વાર આપણે પાછી કરાવવી પડે. તો એ જ રીતના અહીંયા પ્રોબ્લેમનું સોલ્યુશન આપણે ફાઇન્ડ આઉટ કરવાનું છે. ત્યાર પછી શું આપેલું છે? ધી કમ્બાઇનિંગ ફંક્શન્સ શુડ સેટિસ્ફાય ધી ફોલોઈંગ પ્રોપર્ટીઝ. Here some properties are given and we can use that properties. First is, since the order in which evidence is collected is arbitrary, and then we can combine the functions should be commutative and associative. First we can collect the all evidence and then we can combine some functions and check the commutativity or associativity. Okay, next is, until certainty is reached, additional confirming evidence should increase MB and similarly for disconfirming evidence MD. જ્યારે આપણને એવું લાગશે કે એમબીમાં કોઈ ચેન્જ કરવા જેવા છે તો એને આપણે કરવાના છે અને એમડીની વેલ્યુ આપણે ડિફાઇન કરશું. ઇફ અનસર્ટેન ઇન્ફરન્સ આર ચેન્જ ટુગેધર then the result should be less certain that either of the inference alone. Then we can check the inference, our result is right or wrong. Okay, doctor can check all the reports and give the feedback, disease causes, and some instructions are given. By use the CFs, we reduce the complexity of a Bayesian reasoning system by making some approximations to the formalization. Here we can use the certainty factor and we can reduce the complexity. Which complexity? Bayesian theorem's complexity. Okay, and we can make some formula as per our use. So here our topic is completed, certainty factor and rule based systems. Now I will revise the topics which are completed in the unit number 5. Unit number 5 is probabilistic reasoning. In this unit 5 I will start the basic introduction. Okay, and we can take one example, card game. Then we can learn the probability and bias theorem. In this topic one equation is given and we can learn the theorem by taking the example. Okay, and the use of Bayesian theorem is given. Then the second topic is certainty factors and rule based system. In this topic first the basic introduction is given, then we can take the example and explain the certainty factors, and here we can take the two different components in certainty factor. So we can derive one equation for certainty factor. Okay, then some explanations are given Now, next topic is Bayesian network. I will explain this topic in the next video lecture. Okay. Thank you.